nice full room. Oh, glad you're all happy in here to come talk about database and database sharders. Those who have not seen me talk before, I rant a lot and I waffle a lot. And nowadays, I'm free from vendors and big contracts, so it's going to get extra waffly and ranty. Now I'm a freelance consultant, so I only care about one thing: cold, hard cash. Nothing else. I think my objective went, sorry. No, okay. Opportunity. Day rate. Yeah, yes, day rate, hour rate, whatever. I think most of my objectives when I kind of do talks on databases is I'm either trying to do one of two things: whet your appetite, perhaps going to talk to me afterwards or someone else in the community, or to instill fear so you never do this and never call me and I never want to hear about it again, which is also good. Oh yeah, that's me, Richard Bensley. I now work for a little company called Vetabase. I recently left MariaDB after 5 years. We were all let go, so, you know, a good 100 of us. But now I'm with Vetabase, and some of my contract work comes from MariaDB, so, you know, I don't care. I'm kind of free now, which means I'm kind of doing more like foundation work rather than the evil PLC work. And that's our website. You can come for industry-leading database consultants, and this slideshow and talk will be a testament to that, absolutely. And unlike other people who had given talks and things here, something which Alex told me and others said, you know, they don't really like sending their employees to Nordev because they've all got that slide at the end that says we're hiring. So we're not sending them back because they keep going there and they keep getting hired by their companies. But us. Yeah? Cash. Let's go. Database sharding, when was it? This is on Wikipedia a contentious topic for, well, not that contentious for Wikipedia topics, there's far more contentious things. There's two sort of contested titles for it. One's like some boring paper where some sort of computer science company or something like this, and they had something paper about distributing data systems. The other one is Ultima Online, and this one's way better because it has dragons. Instant win. Who cares about anything else? This is the least chaotic screenshot I could find of Ultima Online. I thought maybe I could do a demo of it. That would waste 5 minutes in the talk or something, but it's as pretentious as it's a very irritating game to play nowadays. Let's just put it that way. Anyone played this back in the day? Yeah. Yeah? Missed it?
No, really.
The UI was magic.
Well, it was just one of those games that was jam-packed.
Jam-packed, yeah. Looks like a nice time though. Everyone's parked their mounts outside and they're playing chess and stuff. Yeah. Anyway. So you can watch a talk. Does anyone follow the Games Developers Conference on YouTube? Good fun, good videos. One of my favourite is the classic game postmortems, and you can watch the panel from, I think they're called Origin Systems, and they talk about how they came up with this idea of database shard and sharding for the first time, because they literally had fit various ecologies into one server. And I think this chat was saying something like, oh, we were kind of prepared for 170 players per sort of shard, and I think they sold 15,000 beta copies, so they were vastly unprepared for what was coming, and they had to come up with something. So they came up with this idea of shards. I love their slides as well. I should have done that, just made it some sort of retro throwback fantasy thing. I just chose the default theme, the first one, opened it, file new. That one, that's good. That's all I need. Drag and drop pictures and things inside it. What is database sharding? Honestly, if you've got this far and you haven't just looked at the Wikipedia article, read Data Intensive Applications by Martin Kleckman, great one, I always pull that one up, and that is not on my shelf of shame as pointed out this morning. That is battered, torn out pages, post-it notes and things everywhere. The only reason no one reads Frederick Brooks' Mythical Man Month is you get halfway through and it's all about OS 360 programming. So I kind of don't know anything about it. I just like all the anecdotes before that. Everything else after that is a mystery. And this one I'm reading quite a lot at the moment, starting to burn through that. Site reliability engineers don't get to have all the limelight. We get to have a book as well. Yes, the excellent old Spring 2020 lecture from MIT, hours and hours and hours of them talking about distributed systems and things. And these kind of lectures kind of come up every so often. There's always that refresh in distributed systems, parallelization or something like this. And they're well worth a watch if you want to cancel Disney Plus for that. And of course, you can always just ask ChatGPT, what is a database shard? Does anybody here not know what database sharding is? Okay, is anyone here actually generally here to learn what database sharding is? It's literally the wrong talk. Okay, so if I had to give you a description of what I think database sharding is, I've been doing this for years, and people sort of saying, we've got this kind of issue that we now do face, and we Googled this thing, and it told us about this, or some fancy talk from Silicon Valley said sharding, or we've already got another system that does sharding, we'd like to add sharding to our other things. I call it horizontally scaling for performance and consistency on low-cost hardware. Easy. And I think it kind of comes into two camps, where you're scaling horizontally or vertically. So I think it's pretty easy to, I'll come on some diagrams, just a reasonably nice demonstration of what it means. So why do you get to this point? Why are you asking these questions? What is going on? Who am I? And I'm kind of covering, these are the kind of two camps that I kind of fall into when I'm dealing with database problems or customers with databases. And when we normally go vertically first, and the first reason is cost. Second one is you have to. No one optimizes first, they do it later. Of course they do. When the hardware starts failing and everything's being squeezed in and doesn't really work anymore. Horizontally, cost again. And my favorite one is you were told to, maybe you're failing compliance issues, maybe we can't buy big boxing anymore, maybe we're not going to fall for your crazy experiments and you're going to have to do something a little bit smarter. Vertical versus horizontal. Vertically scaling is very easy. Data, databases, store procedures, functions, queries, queues, consistency issues, hashing issues, all on one big box. And maybe you start here, maybe you're an RDS, maybe you've got an MS SQL instance locally. Oh, that's a good point actually, I did kind of say MariaDB-ish. I'm going to have mostly MariaDB examples. This will or may not apply to your vendor of choice, because I'm mostly kind of dealing with scaling databases which perhaps don't have this built in already. We're adding this, I was going to say solution, we're adding this problem to another problem. Typical vertical scaling issue, one box runs out, add a few more, perhaps distribute the workload a little bit, reads go here, writes go here, reads go here, the other way around would be terrible. And that does happen. They start filling up, you start panicking, so you get bigger ones. For anyone that doesn't know, as soon as these start getting a little bit too big, oh, they get costly. First time I had 100 cores in one box. Yeah, 100 cores. The HP engineers were there every week, changing bits and pieces, voltage regulators, all the RAM came out, power supplies, everything. Garbage. Our little cheap HLDL 360s with 2 U's and 1 socket. Tons of them, wonderful little machines. Never heard a peep out of them. Hadoop, MariaDB on them, scaled forever. Easy peasy. After you've kind of thrown all the hardware you can at it, well, hopefully you've kind of done this bit next, you'll probably start looking at what you can do internally. Ask your database, read the manual. How can I start making this go faster first without kind of spending more money? And the first one will probably be table partitioning. So you already got a table, you'll start chopping it up into smaller tables. And the big idea here really is to reduce RAM usage, make smaller indexes for larger tables. And these kind of chunks, partitions, we move down, kind of move to parts of the disk that won't be accessed anymore. If you've got any old Oracle DBAs on site, they'll probably tell you that they're optimizing the actual platters on the array to make sure that only the center of the disk is read at once. They do that. It's an awful system. Do you get what you pay for? No. Table partitioning. Some of you said, what's that? Does anybody partition the tables now? Some nods, shaking heads. No. Okay. In MariaDB and other things, mostly databases are disks. It's structured stuff on a disk. You've got a fancy interface for asking it what that thing is on a disk, or perhaps putting something onto it. So literally in something like MariaDB, as you start partitioning a table by some kind of partition value set. In this case, I've just lifted this straight from the example from that website. It's a great one. I'll send the links at the end. It's the MariaDB documentation website. So okay, so each year less than these values is in its own partition, which means it's actually in its own files on disk. So if you get to a point where you're not using this data anymore, those pages will never get updated or accessed, and maybe you'll do a defrag or something later, and they'll get nicely optimized and use less disk space and never get touched. And then maybe as the years go on, because time is linear, you'll start adding more partitions, and you sort of realize that's going on. So this has already introduced sort of a level of toil to your systems and schema that your ORMs probably are not doing. Your DevOps or DBAs are going to come along and try and do this for you, or maybe an external consultant. Not everything is that rosy though, and on this page it takes you straight to an example of, you can keep adding, but you can't sort of take away or go alter the past. So already on a vertically scaling issue on a single instance, you're going to start coming across these issues like, I actually need to reorganize partitions and do different things, and depending on the sort of like transactional isolation levels you're doing, this could take a long time if you're trying to move a lot of data from one to another. Maybe you're archiving. So, we had this genius idea of horizontally scaling, where we've got one big table, we've got all these nice cheap servers, or even the big servers. We think, I know, we're going to actually put these partitions on different machines. Whoa, whoa, like that. Whoa, whoa. Then what you don't generally do is you've got a picture somewhere, a ghost table, which kind of knows what these tables are, and it's kind of got its own picture of these partitions. We'll come back to that as a better example. So then you kind of create a ghost table that knows where these kind of sections and segments are, and you can also host that on these other servers, and they all kind of know which one it is. So I can come and make a query here, and it'll still select from there, and I'll still get all the data together. Whoa! So in this case, I'm changing my partitioning scheme again from range to using a hash. I'm going to hash on the primary key, so as new rows come in, it's just going to distribute hashes accordingly. 1, 1, 1, 1, 1, 1, 1, 1. Easy peasy. And they've just got a little few things in here. There's a little few extras in my partition comments, so I don't actually have like what it is partitioned by, just where it is. And in this case, server 1, and I've got a little comment in there. Now, a table represents by T1. In the new version of Spider, actually, I'll come back to what Spider is, these aren't comments anymore, they're actually keywords. Looks a little nicer. So now I've got a table somewhere which has the same sort of data structure as these other tables, but they're somewhere else. So that's a rough example of sharding by table definitions. When you start kind of thinking about how you then need to present this structured data to someone, you need to figure out how you're actually going to handle this partitioning versus, and this is where I'm going to come into partitioning versus rules. And as we keep seeing today, memes are now so passé, we need to generate pictures of things. And this one's a realistic photo of an average JavaScript developer, I'm sorry, trying to use a database. And I think we've found the perfect one. I thought, this is just my life day to day. There he is. Okay. So, the developer, whoever they are, client coming in, needs to select from this kind of sharded data set, and as far as they're aware, this is going to go to a node somewhere. This kind of ghost copy of the table is then going to perform the aggregation, the join forming, and to me, it's just seamless. I don't care anymore. It's fantastic. But that means, in this kind of base example, I'm kind of keeping all these servers know about each other, which is quite complicated. Or you can have the server kind of away, which has just one ghost copy of the table, and it knows where all these are. And that means this server's tiny, this is kilobytes in size, this is just a schema. And a backup is easy to do for that, to provide fault tolerance or even just more traffic, because even a query going from this one to these ones is still atomic, or isolated, or durable, or all of those things. Partitioning by rules, though, means that you've probably got some kind of software here in the middle. This could be something like Proxy SQL, which will come up a few more times, which is like a SQL knowing router that you can kind of put in front of various databases. Postgres is one called PG Proxy or something like this. And I'm sure there's ones like Microsoft as well, as IBM Pure Scale, all this kind of stuff, or Federated, something or other. Something, whatever it is, it costs a fortune. The idea is, although we've got kind of like the data separated, they don't actually know about each other anymore. Only this knows what is going where. I kind of wish I had included an example of more rules in this one, but I haven't. I'll be linking to a gist at the end, and I might find a nice little example to stick it on the end, perhaps before tomorrow, for anyone that looks at it, of how that would kind of work. I'm kind of focusing on the definition kind of based on the rules one. Is definitely a lot more flexible. But another advantage of whether you're using rules or table definitions is the definitions don't really know, they know about the other tables and where they are, and probably what's in them, perhaps some kind of range, but they could also be different partitions. So you could be going to an OLAP column store for fast queries and aggregate queries, or you could be going to a table stored on S3, and again, your developers and applications don't know about it. Particularly good for like large data lifecycle workflows, particularly if that is like 2-year-old beyond data, some kind of GDPR nightmare. That's kind of the basics of what I think what I pay attention to when I'm looking at horizontal or vertical scaling, and then how I kind of put rules and definitions on top of it. I still come up with some of these pros and cons. Vertical scaling is easy. That's the whole point. It's got one box, and if you read the manual of your database, whatever it is, wherever it is, cloud, on-site, Raspberry Pis, on your watch, there'll probably be some mechanism for you to duplicate it, point them at each other, and they stay in sync. Wherever that is. Horizontal sharding means you've got people doing that, some kind of software doing it for you, or a classy consultant doing it for you as well. Mitigating application changes is also quite interesting. Vertical, again, reading the manual, feel like your database connector, maybe your C# or ADO or JDBC driver has these extra parameters for putting in extra server details. So perhaps if one is not responding or it's taking a little bit longer, it will try another one in the queue and just keep round robining it, going round in a circle until it gets what it needs. Unless you're using some kind of proxy or something in between to keep that all hidden. If you go into the horizontal route, I mean, that's up to you. Maybe you don't want your queries or applications to know what's going on. Maybe you start doing it like region specific, even though you have one view of all your data. Your applications still only get like region or group specific views and actions around it. It's cheap, yes. Not the consultancy. Simple backups. Yes, in vertical scaling, every server's got the data. And as long as it's in sync or reasonably up to date, run a backup. Simple as that. Restore it to another one. That's the scaling strategy. Copy one to another. Horizontal backups, sharding backups. Oh, that's a nightmare. Easy way to do it is back up every single server all the time. That's it. That suddenly sounds sort of less cheap, doesn't it? Yeah, and does anyone notice a problem with this very basic sort of like sharding definition? Like, what's wrong here in this very basic diagram? I definitely didn't write yesterday.
No usage between the shards, as in overusage on the individual shards.
Yeah, really, that's down to you and your application. So I do like the idea of like a hash extends to evenly distribute data, but it doesn't mean that you're effectively using that data. You can still be pushing most of your queries for that day or hour or minute to one node, and it's still doing a lot more work. That is a good point. And then that kind of comes up to the toil that comes with managing sharded clusters, that you have to maintain those partitions. And if you think that actually your sharding strategy doesn't match your query strategy, your traffic strategy, ooh, that's a big migration. And unless you're using something automatic like Cassandra or Mongo, you can kind of just shuffle it around. If you're doing something like this, we probably scripted it, you're in for a long weekend. But the thing which is missing is there's no actual fault tolerance or high availability here. These are all kind of individual servers, but they could also be individual server clusters. That's the wrong way. There we go. So how do we kind of make these shards scale? Vertically scale the shards. Easy. Then back up all those as well. Then this gets far too much complicated to start querying. So you add an aggregate server at the bottom. And Dave, the developer, has no idea what is involved here. He says, can we make a scheme change this weekend? No, Dave, shut up. It's Friday, go home. Okay, how much time have I got left? Do I know?
You have
Sharded.
17 minutes.
Oh, that's not too bad. I'll slow down a little bit then because I don't have as much content as I'd like. Great, we can tell a joke in the meantime, yeah. So these are the kind of things that I play with and use most of the time. This is what most customers ask me for in MariaDB world. You know, I also still like Cassandra and things like this because I just turn it on, we set a kind of key distribution, figure out how much data needs to go in, have a scaling and an upscaling, downscaling strategy. That's kind of it. Put on a nice bit of paper, charge a fortune for it. So Spider's nice, this is kind of built in. Some of these partitioning details and what I'm going to go through next is kind of just all in Spider. Proxy SQL sits in front of it. Data sharding rules, the documentation is a little bit brief, but it's just to show you that queries coming in that look like this will go this way, some will go this way. That's definitely a lot easier to distribute queries if you're just doing it at the router level and it's just rule-based, definitely. But you could still overload your router if it's trying to make too many logical decisions to route that traffic away. Then you've got to scale your router. Connect engine is a lot of fun, particularly if you want to connect to other databases, so I could still have a table definition and that could live everywhere. I'm pretty sure Excel spreadsheets are supported by the Connect engine, so you can start sharding your data over Excel spreadsheets. Call me for that as well when that goes wrong, because I'd love to see that. I've got this really convenient URL which we're going to look at now, where I've got a little bit of SQL just to go through, just to prove that it does work. I promise. And then I managed to get SpiderDB as a tiny URL if anyone wants to play with that. I think that's it. Yeah, that's it. I'm going to Alt-Tab and go over there and crouch awkwardly. Oh, we're going to look at a terminal, which we can't really see. Yes. Right, is that too light, too dark, too big, too small? Mm-hmm. Yeah, too bad. Okay, so I've just got a bunch of DDL inside one file. If you look at the GitHub, I've just got a few things in there, just how I installed. Oh, we could probably look at that. Nah, that's not. Actually, one thing I did set, which I should show you. Spider.conf. I've added one parameter as well as turning it on. Just Spider link, same server, because all my partitions are on the same server. I absolutely do not expect people to go away and fire up like a 16 gig, 28, 64 gig cluster on their laptop just to play with like one table definition where we're going to show like the data being split and being queried back. Fun. Okay, for this unreadable blurb, just doing some housekeeping first. Normally this would be on every server, not just one server, so I need a user for the Spider table to connect to the other servers. And the create server definition has been around in MySQL MariaDB for a while, and in other databases as well. And it's quite literally just some parameters, where it is, what it is. Simple enough. 3 server definitions. I'm going to create 3 separate databases, including the core database where my Spider table exists. I'm just going to drop them all if they do exist. Create them all, nice and simple, ID and a timestamp, which is just now, and a value integer, and that's about it. Then we get down to the interesting one, the Spider table. So Spider is a sharding storage engine. Can't remember the name of the guy who wrote it, but he's Japanese. He doesn't speak English. His wife does, and she drags him around to all the conferences. Vice versa, and those are interesting technical conversations. I can't tell her she's excited to be there. So we just create a normal table, create the same table with just a few extra parameters. The engine is Spider, a few extra comments in here. Does I say, I promise us a table, how we're partitioning by hash on the ID, and what servers we're going to be using, which have already been defined upstairs. Right. Just going to source that. Shows nothing up my sleeves. Done. Excellent. Show create table. core.t1. Excellent. We also just have a load. I'm just going to load a sequence into that core table of data, just some random integers multiplied by another random number. 300 rows in total. And can anyone guess on a hash distribution how many tables there will be per, how many rows there will be per table? 100. There's no money for that. There's just. I think
trick question.
Yeah. Yeah. We'll just source the load. Oh, .SQL. Excellent. 300 rows, 100 per table. And I do just have a query. I'll just clear that screen. Query.SQL, which will run a quick query and show us where everything is. Ta-da! That's it, we did it! Now you can all go home and shard everything and cause a headache and a nightmare for all your admins and DBAs and things like this. And I can just do, just a quick test. Can't start from DB, no, always do that, from db1.t1. There we go. We just look at the query on the way out. Okay, and that's it. This seems super simple. Well, of course, on a larger scale, it's not. Well, it can be. Depends what you do. That's a big one, isn't it? Depends. That's the end of the demo. I hope I whet your appetites, or I've disgusted you entirely, and you're never going to see or do this again. And just use a cloud product and just don't care about it. Any questions?
Talking about cloud, we're talking about cloud. How and where this is used already when we use like an easy cloud solution, like I load an RDS and I just don't care about anything because they do care about everything for me.
So, well, they take care a lot for you. They've got their scale-up solution, which is Aurora. So they do a different thing. I have read the technical paper on how they supplanted the NODB engine. I actually can't remember how it scales, but they're doing something. They're actually doing some kind of data block allocation. They change how NODB stores data on disk somehow. What kind of distribution method that is, I'm not sure. So they've already kind of got one that's a bit seamless.
Yeah, just it was the thing you always like trying to balance. Is it like the bare metal? I do everything against do I have the money to invest and throw in some cloud solution that I definitely come from the old style, but in the last few years I definitely appreciate it.
Oh yeah.
Much, can forget about that. If money it's not a problem.
Yeah, particularly as I'm in that consultant range now, I sort of tell them it'd be nice to do some of these projects sometimes. I say, well, money and time would be better spent if we just use Bigtable, Google Bigtable or something, because surely you care more about the data than where it is or how it's distributed per node or something like this. Some of the end goals I have for another big customer is to keep that kind of seamless to them. So developers and users and data warehouses, they don't care. They just have endpoints and gateways and things, and I try my best to make that work. Intel update, great.
Yeah, okay, I'm just...
You at the front first?
Yeah, sorry. When you're doing a query, say you want to get the first 20 records against some where clause, how does it know? I mean, potentially it has to go to all of the shards, right?
Sure.
And then...
And if it's waiting on one longer than the rest.
Does it have to get 20 from each and then do the combining the data on the...
Yeah.
So that's not very efficient.
Well, it depends on the network latency and things like this. So even though, let's say these HP DLs and these kind of ProLine to user are still pretty cheap, and I'm pretty sure like 40 gigabytes a second is like the standard Ethernet adapter now. I've still used InfiniBand for that kind of, I don't know if anyone still does for any more, but you can throw little patches and things in there in between to make that happen. If you're doing it across networks, VPNs or clouds, very slow. And you will always be waiting for your slowest query thing to finish. Particularly if that isn't like a well-distributed system. You're returning 1 billion rows from one, perhaps 2 or 3 from another. And that's been in sort of more clustered, like what we call two-phase commit systems, where we're trying to keep data in sync, but also trying to localize queries. People are probably familiar with the concept of like a fact table. Terabytes in one table, and you're joining onto something smaller, like postcodes. Postcodes might be on a completely different server. And some of these query coordinators in like clustering tech will move the query to happen where the small table is. So all the data comes across and it's dropped. Brilliant.
So are there certain types of query that you should try not to do when you're using sharding?
Medium?
median value.
Yeah, I guess any kind of like large aggregate queries, which I'd always encourage to go to a columnar store. But even joins with sensible where clauses on keys is fine.
Backups. You said continuously back up everything. Are you talking about just continuous replication? And if the worst does happen, do you just have to rebuild everything? Is it a world?
So in like automation strategies, as I've kind of had like a front end to, well, I say front end, I mean a command line tool to create a definition, servers are underlying it, a backup job is created, and it very simply name everything after the asset, what it is and where it's coming from, and sort of the range of data with it. Because I think that's what you'll notice first. You might not notice a server's gone down, you'll notice like a class of data or asset has gone down. Then I need to go fetch that one. It's very lazy just to kind of take a backup of every shard or every node. And with that, just have like text-based DDL of like what was here up until when, and that's a reasonably easy way to kind of, at least for me, when I would kind of do that. Does that make sense?
How could Sharding help you on a vertical database? You mentioned about separate files. Does that then lower the memory footprint of the machine as it's running?
Yeah, so partitioning data on even as a single node. MariaDB, InnoDB in particular uses individual files for the tables. So if that, and as well as the index. So the basis index and data are two different files. If they're two different files for each kind of range or more, then you are only accessing one file. It's not uncommon to kind of, on really busy systems, to hit things like the U limit, the file open limit. So one of the first things I always make sure U limit globally is 65,535, because otherwise I'll run out of files for the database to actually open. So if you can partition to kind of keep that a bit lower, that's an odd optimization, but it does happen. Particularly as if the index is another file, that's one less or a smaller range of data that needs to be read into memory and updated.
Just kind of touching on the point that I was kind of asked earlier. So if I'm partitioning per year, say if I'm just partitioning on the year that's in one partition, will I just work in that one partition, or will it wander over into the other partitions?
Only if the where clause, or your partition clause and your where clause kind of wander out, but otherwise it will stay in. Ask your query planner.
Yes.
Yeah. Always put for MariaDB MySQL folks, explain everything.
Go on, another one. I'm going to try and get some free consulting here, I think.
Watching the grift now, okay.
So you mentioned something about spreading your load across the servers. So I think of two approaches, like one where I partition or chart by, say, project or user, so that a particular user's requests are all going into a single machine, and together all my users will be shared across machines, versus like another by time, by year, like that give it a more, so a single user would get spread across shards.
I think like for any kind of database like this, or any kind of scenario in this, if you're kind of mixing workloads and data types, you're going to not be able to scale for every strategy of every query that comes in. It's not uncommon for, especially as we have like routers and the connect engine and things, some kind of layer on top. We're not scaling like the entire database cluster. We are just scaling one table, and that's just kind of one query pattern that is associated to that. I mean, you can still have multiple tables, and they've got their own kind of different shards and things, so that's fine. But if you're trying to take in multiple query strategies to the same table, and they're vastly different, maybe use a different solution.
Do you really want to direct one user to a single shard? Like one query comes in, ideally you just like a single shard to be dealing with it, so you don't have to deal with combining data together. That's absolutely the point. If you've got 3 or 4 users coming in and the same data is in multiple places, they could all be using a different resource each. Got the free consultancy, thank you.
It's all right. I'll find you later at the bar. Any more questions?
A question on your server, which I know is not very sharding, but I was curious. Each of your servers use the same port. If you, in a real case scenario, would you not have have your servers running on separate ports and tables and stuff like that in a real case scenario?
Sure. I mean, I was only kind of another half hour, perhaps an hour from
but
another.
I'm thinking just the system we've got is that we're firing everything through a port, and I'm going. Actually, I didn't know we could do that. Nobody has said everything because everything's configured. We're hitting 4 servers through onto separate ports.
I guess ports kind of help with server separation and definition and things, particularly if you're running multiple services on the same hardware or endpoint.
Yeah, so it's help. Free consultancy, maybe in the bar later.
Most databases need memory per connection.
Yeah, okay.
1 minute. I mean,
how widely used is Spider? Is it like
one client when I was at MariaDB, I can't say the names. They weren't like a sticker name. They've got over 400 servers, and they deal with most of the retail shops for like a big POS system, and that was gargantuan.
Is widely used
By some when it's I think it's more like, oh wow, yes, let's get a Hadoop cluster or a Spider cluster. Oh no, I need to scale 4 petabytes and it needs to be available. It's often more problematic than like an exciting opportunity, particularly as now I'm self-employed, being dragged into these scenarios like, can you help us with this? Oh, everything's on fire. So I mean, I would never start with a Spider as my solution. I'd start with SQLite or a CSV file and be completely ignorant of the future. Thank you everybody for attending my talk and enjoy the rest of the conference. Yay!